Today we're going to take you through the process to time an aircraft engine. We're joined here by our lovely assistant, Natasha. In terms of preparation, one of the most important things is to make sure that the aircraft is in a stable position. It's not being moved. There's not other people crawling in and out of it performing maintenance. Otherwise, it'll throw your readings off on the digital inclinometer. So our aircraft is stationary, and we're going to go ahead and remove all the upper spark plugs. We've now got all the upper spark plugs removed, and removing all upper spark plugs will allow us to rotate the crankshaft easily because there's no compression, and safely because no cylinders are going to be able to fire. Next, we're going to prepare by hooking up our Magneto synchronizer. Again, you can use any model with this system. The goal of positioning the digital magneto timer is to have the face of the inclinometer mounted parallel to the crankshaft flange, or in other words, perpendicular to the crankshaft itself. Now that we've got that secured, we're going to find compression on the number 1 cylinder. Which is our number 1 cylinder on this engine. Perfect. Go ahead and place your finger over the spark plug hole, rotate the propeller in the forward direction until you feel compression building. If you ever forget which direction is forward, just look at which edge of the propeller has paint flaked off. Continue rotating until you feel compression building. Perfect. You heard the air hissing past Natasha's finger, so we know we found the compression stroke. Go ahead and install the piston stop. Piston stop is now installed. Always install it by hand, don't use tools. We're now going to locate top dead center on the number 1 cylinder. The general way this process works is that we're going to contact the piston stop with the piston on both sides of top dead center, equidistant apart, and then we're going to divide that reading by 2. Halfway in between those 2 points is going to be top dead center. And with this juicy, beautiful cutaway engine, we'll get to see how this actually goes down inside the cylinder. Alright, piston stop is threaded in, and now we're going to continue rotating the prop in the forward direction until it hits the piston stop. And right there, it's hit the piston stop. We're going to turn on our inclinometer, zero it out, and the magic of this is that we're going to rotate it all the way around the other direction until it taps the piston stop on the other side. Alright, there is the piston stop on the other side, and we're showing a reading of 49. And so from that we can tell we've hit the piston stop over here, we've hit the piston stop over here. Halfway in between those 2 points we know for sure is going to be TDC for this engine. So go ahead and turn on the inclinometer and rotate the propeller in the forward direction lightly and slowly until you contact the piston stop. Perfect. And zero the inclinometer against the piston stop. Now go ahead and rotate the propeller in the backwards direction all the way around until it again comes into contact with the piston stop. Write down that reading. What do you have?
62.2.
All right, I've written down 62.2. I recommend always performing this part of the procedure twice to double check yourself. So Natasha's going to again come into contact lightly with the piston stop. Go ahead and zero there. And again, rotate in the backwards direction until you contact the piston stop lightly and slowly.
62.5.
62.5. You want the two readings that you wrote down to be within a few tenths of a degree of each other. If they aren't within a few tenths of a degree of each other, go back and troubleshoot your process. The most common issue is that the aircraft is not stationary. In our case, our two readings are very close, so we'll go ahead and divide them by 2, which will give us 62.4 divided by 2 is 31.2 degrees. At this point, you can go ahead and remove the piston stop. Perfect. And then continue rotating the propeller in the backward direction until you get to your reading divided by 2. In our case, that's going to be 31.2 degrees.
.2.
Perfect. That is the exact location of top dead center on the number 1 cylinder. Go ahead and zero out the inclinometer there. And from there, it's quite simple to find your magneto timing position. Simply rotate the propeller in the backwards direction until you're at your magneto timing position. For us, that's 24 degrees before top dead center. Perfect, exactly 24. Zero out the inclinometer. And the inclinometer is now zeroed out at the magneto timing position. From here, simply follow your normal magneto timing procedure using your own magneto synchronizer. We can show ours. Go ahead and turn on the magneto synchronizer. Rotate it forward to make sure your impulse couplings fire. Okay, go ahead and go back. Yeah, that way. Okay, good. All right, both of our impulse couplings have fired. We're now ready to rotate in the forward direction and see what our magneto timing is. All right, 1.3 for our right magneto. And 1.8 for our left magneto. Perfect. That is how you check the timing on an aircraft engine. Thank you all for joining us. Thank you, Natasha.